So now we're going to look at a velocity versus time graph, okay? So that's where we have on the y-axis the velocity and the horizontal axis is the time. And so the slope is going to be that change in that y variable over that change in that x variable, right? And that's going to be our average acceleration. Whether it's average or instantaneous kind of depends on whether you're doing an instantaneous slope or an average slope, right? And then so that's going to be that. And then the area, we'll also have to do area on this one because the y variable times the change in the x variable is the displacement. Because remember, we have our equation, our velocity is the displacement over the amount of time it takes, right? And so you just rearrange that, move the delta t up here, you get that the area is going to represent the displacement. So when we have a slope of a velocity versus time graph, it's going to give us our acceleration, and the area is going to give us the displacement. And the y value is the velocity, so you can ask all kinds of nuanced questions about the velocity versus time graph, and you want to be able to translate the information in the question about the graph into those kinematic variables. So let's kind of go through it. So we have a velocity versus time graph, and let's just re-emphasize again that the y value is the velocity, the slope is the change in the velocity, change in the y variable, the change in the x variable, that's the acceleration, and the area is the y variable times the change in the x variable, and that is the displacement. Okay, so those are three things we're keeping in mind. Now, when is the object at rest? Well, that's when the velocity is 0. Now, what is the velocity in this context? Last time we talked about the position versus time graph, the slope being 0, but now the y value is the velocity. So I want to know when the y value is the velocity, is 0, right? So when is the y value 0? That's going to be 0, 25, and 45 at those times. So t is equal to 0, 25, and 45 seconds. Okay, look. All right, so B, what is the acceleration at t equals 25? Well, the acceleration is based on the slope. So at t equals 25, we want to look at the slope equaling the acceleration. Let's look at the slope. Well, it's a straight line, so you can just calculate the slope. We notice if you go from here to here, for example, you're going to go over 5, and you're going to go down 2. So it's going to be negative 2 over 5, and that's negative 0.4. Now, what are the units? Well, this unit here is meters per second. This unit here is seconds, right? The y variable is meters per second. So meters per second divided by second is meters per second squared, right? And that's our SI unit for acceleration. What is the displacement between 15 and 30 seconds? Okay, so now the displacement is where we're going to look at the area. So now we're saying, okay, between here and here, I want to know all of this area. Remember, it's the area between the horizontal axis and the graph. It's easy to make a mistake here. So let's make this a rectangle and a triangle. So this area here is a width of 5 and a height of 2. Look at the y values here. So it's 2 by 5. So it's 2 times 5. That's 10. And then this one here is going to have a width of 5 as a triangle. So the width is 5 and the height is 2. So that's going to give you 5. And then the area here is you're going to do 1/2. And that's negative area. So the width is 5. And then, because the area of a triangle, and the height is negative 2. Okay, so this should be negative area, which is why we get a negative number here. So it's a negative 5. And then you just add those all up. What's the total area? It's going to be 10 plus 5 minus 5. And that's going to be 10 meters. Why? Because remember, the area, we look at the units, it's meters per second here. And then the time is seconds. Those will cancel and we'll just get meters. And that makes sense. Displacement is measured in meters, right? At what times is the object speeding up? So we got to remember, what did we do for the speeding up and slowing down? How did we identify it? Is whether the sign of the velocity, the direction of the velocity and the acceleration, whether in the same direction or the opposite direction. So we want to look at the sign of velocity and the acceleration at when it's speeding up. Now, they need to have, if they're the same sign, which means the velocity is positive and the acceleration is positive, then it's speeding up. It also could be they're both negative. Okay? So let's look at the two different cases. I want to know where the velocity is here. That means the y value in this case would be greater than 0. And here the acceleration is the slope. That means the slope is greater than 0. So for the first case, when both velocity and acceleration are positive, that's when the y value is positive because the y value is the velocity, and the slope is positive because the slope is the acceleration. So when does that occur? Is here, Okay, here the slope is 0, so it's not speeding up or slowing down. Here the slope is negative. And so this is the only time, this is the velocity being positive because it's above the x-axis, positive y values, and the slope is positive here. All right, now let's take a look at the other case where the velocity is negative. That means the y value is negative, and the acceleration is negative, means the slope is negative. So that's in this region where the y value is negative. Where the slope's negative is right here. Here in this region, the velocity is less than 0 because the y values are below the x-axis. You see they're negative y values. And the acceleration is negative because it is a slope that is down and to the right. That is a negative slope. So this region here, not this one. This one is going to be slowing down because the velocity is negative, but the acceleration is positive in this case right here because the slope's positive. That's the acceleration, and the y values are negative. So here it's going to be slowing down. So it's speeding up between 0 and 5 seconds over here, as well as between 25 and 30 seconds in this region here. Okay, like that. All right, let's look at another example. So we have a motion of an object is shown in this velocity versus time graph. And again, the y value is the velocity. The slope, you should write these down every time until you just know them instinctively, right? This is the part of the process. The slope is going to be the acceleration, and the area is the y variable times the change in the x variable, and that is going to be the displacement. So let's take a look. Object is shown in the velocity time graph. What best describes that motion of the object? Okay, so let's take a look at this. In the entire time, the velocity is positive, right? So we know that. How about in terms of speeding up or slowing down? We know that here the acceleration is greater than 0. Here the acceleration is less than 0. And here the acceleration is 0 because those are the slopes, the acceleration being the slope. And then the area under the graph is the displacement. So the object is either speeding up or slowing down the entire time. This is not true because there's a time where the acceleration is 0, so it's not speeding up or slowing down. So it's speeding up here because the velocity and acceleration have the same sign. It's slowing down here because the velocity and acceleration have opposite signs. But right in this window, the acceleration is 0, is not speeding up or slowing down. So it's not A. The object starts and finishes at the same position. You translate that. That means the displacement is 0. Right? In terms of position, in kinematics, if we're start and end at the same spot, that means the displacement is 0, right? Is the area 0? No, because this is our x-axis. That area is definitely not 0, so that's not true. The object travels in the same direction for the entire time. Well, the direction is based on the sign of the velocity, and the velocity is positive the whole time. That one is true, but let's eliminate D. The object undergoes positive acceleration the entire time. We can definitely see that's not true because we have negative acceleration during this time. So it is C in that case. Okay. Thanks for checking out this video. I hope you found it really helpful. If you'd like more support, maybe you need more multiple choice practice, maybe you just need more guidance and things like that, I have plenty of information on my website. If you look in the description below and go to www.bothellstemcoach.com, I will explain all the ways I help students be successful in their AP classes.